Very cool. So let's go ahead and get started, shall we?
Yes.
Awesome. Well, thank you everyone for joining us today for another webcast. This is just part of our, ongoing series of webcasts that we're going to be doing from now on. We had one of our first ones of this nature last month. It was called Cypress in a Nutshell. And if you're interested to get up and running with Cypress quickly and you're not fully acquainted, you can go search for that on YouTube and get going with that. But today we're going to be talking about code coverage. I'm joined by my friend and colleague, Gleb Bahmutov. How are you doing, Gleb?
I'm doing excellent. Hi, Amir.
I'm doing great too, thanks. All righty, so let's go ahead and jump right into it. Let's see, there we go. Awesome. So today's topic is code coverage, and this is going to be our agenda for the day. We're first going to talk about why you even need code coverage in the first place. And if you're not familiar with the topic, then you'll definitely get acquainted with us today. And then we're going to look at, the state of, how code coverage is done in the JavaScript world. Then we'll see how we can apply code coverage to our end-to-end tests and see how unit tests kind of add to that story. And then we'll see how we can accomplish full stack code coverage as well. And throughout the talk, we'll not just be talking about concepts, but we'll also look at real examples. And I think you guys will find that really helpful. Another thing to note is that we're going to be accepting questions on Slido. So you can actually go to sli.do, and then you can type in this event code CYCC, and here's the actual link for it. There you go. And you can ask your questions here, and people can upvote questions. And at the end of the talk, we'll go ahead and review the questions and get them answered for you guys.
And Amir, can I ask you something? So we're doing this for the first time, right? Using Slido?
Yes,
it's our first time. Is there anything specific about Slido that you want to mention?
I should mention that Slido is tested with Cypress. They're Cypress users, so we're very happy to use them today.
So hopefully everything works well.
Hopefully. It's a well-tested app. The well-tested app. Awesome. Let's go ahead and continue. So why code coverage, right? Why should you even care about code coverage? Well, the thing is, you're going to start a new app or you already have an app, and you begin to write tests. And as you write more tests, things get more complicated, right? Complexity adds up.
But Amir, can I interrupt and say, yeah. Cypress does very unusual thing, right? It claims at least to do an unusual thing.
Yes.
And what's that unusual thing?
Well, it does many unusual things, but the thing that it really does is it makes it really easy to write tests, right? Cypress helps do that. It's got a nice API that allows you to easily and quickly write very big tests, end-to-end tests especially. So, you're writing your app and you're writing more and more tests, and you start to wonder, hey, am I testing my app enough? Do I have enough tests, or am I over testing? Do I have redundant tests in my test suite that could be adding to the build time, right? You have these constant questions going on, and how can you go about, getting answers to those? And this is where code coverage comes in. So, the state looks kind of like this. If I can get my mouse going here. So, you write your first test, you're happy. And then, you're going to write some more tests. You got, things are viable still. And then you got a whole bunch of tests. And then you're living life like this fisherman, just completely overwhelmed, don't know how to handle the situation, right? So code coverage is going to be your friend here. So Gleb, do you want to elaborate on, on how code coverage kind of works?
So let's say you ask yourself, are we testing all the features of a particular application? In this case, let's take a very simple to-do MVC application. You can find many online. So what's the feature number one for a to-do app, Amir? Like, what do you think should be?
I want to add a to-do.
Exactly. First feature is users should be able to add a to-do. A second feature, you probably want to complete a to-do. And the third feature would be you probably want to delete to-do. So, okay, let's start writing tests. And at first, we can keep track of what features we have tested manually. So we can name our test the same as a feature. And then if we do everything correctly, right, we say, oh, we're actually lacking any tests because none of the tests actually is named delete to-dos. And we'll write one, and we completely tested our application. But of course, that requires a lot of discipline, right? That requires to manually keep track of the tests and the features. So it doesn't really scale, I think. So instead, we're trying to do something else. We're trying to use the code coverage as a proxy to features. And it works like this. When you implement feature A, adding to-dos, you probably write some code. And then you implement feature B, and you probably add more code, maybe change some original code, but now you have more code. You implement last feature, adds its own code. So instead of kind of trying to separate tests by feature, you say, okay, if I have two tests, and if I somehow know which lines of code they actually execute when they run, let's say mark them in green, then I know that there are missed lines of code. I don't know where they're coming from. I can look at the code, try to determine what features this code implements, and then I know this is not tested, so I'll add one more test, and then I'll hit all the lines. And I know that all my features tested by the tests. So the code coverage allows us to indirectly measure all the features that we are testing. And of course, Amir, you can ask me this question.
Yeah. So, I mean, are you promising me that if I have 100% code coverage, that I will have no bugs?
Absolutely not. Unfortunately, I would say.
Oh.
So, and there are two sources of the problem here, because there are two indirections. One is that our code might not actually implement the feature correctly. There are logical bugs, errors in our judgment, errors in our code, the way we actually wrote the code, right? So our features are not necessarily implemented correctly. And second, our test might be unrealistic. For example, we might use a particular email as an example and never test other types of emails. And that leads to the user discovering a bug later in the system, even if it's covered at 100% of code. All right, Amir, can you walk us kind of through what's the code coverage? How do we do it?
Gotcha. So, setting up code coverage is going to take 3 steps. First, we need to figure out a way to instrument our code so we can know which statements in our code actually get executed. Then we need to run that instrumented code to actually, execute those statements. And then finally, we need a way to figure out how to gather the results of all the code that got executed. We need to generate a report and see how everything got executed, or if something got executed. So let's go and see how we can do this. Well, the first step is to figure out instrumentation. Let's look at this simple example. We got just a bunch of console logs, and let's look at what this statement is actually going to do, right? And since you're all geniuses, you've already figured out that first it's going to log out A, then B, then D. It's going to skip C because if equals true, is always true. After that, so let's see how it actually gets executed. Got ahead of myself there a little bit. So console log A, then B, then C will not get executed, and then D.
But Amir, you did this all in your head, right? Because you're super smart.
Exactly. This is exactly why I'm here. It's for these specific skills.
What about more complex examples? Can you actually do it by a machine?
Well, let's see. That's what instrumentation is for, right? So how can we go about programmatically tracking the execution of these statements? Well, we can assign counters to each statement. And as the code gets executed, we can increment those counters. So, for console log A, we can assign it the counter at index 0 of this of this array, which we're using to store all the counters, and so on. So as the code is getting executed, we're incrementing the associated counter for that line. And then after we're done, we can execute out the whole array and see what the final result was. And this is, kind of like our rudimentary coverage report. And then, we can run it like this. And from this, we can infer that we have 80% coverage of our statements because 4 out of the 5 lines we executed actually ran. And we know that because their associated counters got incremented. Cool. So we got some of the initial building blocks for reporting down. But we can build upon this. So we can, build a nice HTML template around this, and then we can, include our code in that in that HTML, and then we can highlight the lines that actually got executed. So for example, we can show a little nice green numbers for the ones that got executed, and then like a red for things that didn't get executed. Awesome. And then, the thing is, you don't want to do this by yourself, right? You don't want to reinvent the wheel. There's already tools out there that can help you with instrumenting your code. One popular one is called Istanbul.js, and it's a code instrumentation library that you can use. Now, to be productive with it, you want to pair it with another library called NYC, which is a nice CLI tool, client really for NYC. And you're kind of, seeing a trend here of projects named after cities. So let's see how we can use NYC and Istanbul to instrument our code and generate reports. Cool. So we go back to our console log example here. And then let's go ahead and install NYC into our project. Cool. And then once we run, our project with NYC, it's going to create this nice little table in our terminal, giving us that same report that we saw earlier. So we got that 80% of statements here. Awesome.
It's kind of nice, right?
It is.
The same numbers from like battle-tested tool, like
exactly.
we did manually. It's nice.
It's good confirmation.
Good confirmation.
Cool. So we got this. That's great. But we can also, use NYC to generate those nice HTML reports, right? So we can use NYC in this manner by using the reporter flag and saying, hey, we want an HTML and so on, like this. And then it's going to generate this, coverage index HTML for us, and we can go ahead and open that up, and then we're going to get a nice little report like this, and it's going to highlight the lines in green that we did get executed, and it's going to tell us how many times that line got executed, and then it's going to highlight the ones we didn't in red. Cool. So now we go back to our example, and then let's look at how the instrumented code actually looks like. If we go ahead and print out, how Istanbul does the instrumentation, we'll see this, this global coverage right here. I guess let's see if I can highlight it. There we go. This coverage global. So, and you can also see some other interesting things here. Remember those counters we were talking about? Istanbul is doing the same thing. It's assigning counters to every statement in our code. And we can also see it incrementing those counters as the code is getting executed. So this is the same console log, if statement situation we had up there, and the bottom is the instrumented version. And then if you pull up DevTools, you can see this coverage global. And if you see this, this means that your code was instrumented. And you can go ahead and look at this global coverage variable, and it will give you all the instrumentation information. So it's kind of cool. It always helps to know how your tools work. And there's that. Awesome. So Gleb, can you tell us now how we can use code coverage, now that we know how it fundamentally works, how we can use it in our applications, especially with regards to our end-to-end testing?
Absolutely. And thank you, Amir, because what you just showed, instrumentation, running the code, and then generating a report is exactly what you would do for your web application. You would instrument your application, and I'll show how. You would run Cypress tests instead of executing a node program. And then you would have to collect that coverage, save it somehow, and then generate reports. So how do you instrument your web application source code? Well, the easiest thing is, if you use popular transpiler Babel, is to add one more plugin. It's called Babel plugin Istanbul, not surprisingly. And all you have to do, add it to your Babel RC file like this. Just one more plugin, and then your code will be instrumented. You probably don't want to run instrumented code in production though, right? So you probably want to insert that plugin only if you're running in test environment. So Babel RC allows you to add plugins only in environment, for example, named test. So when you start your web application, when you start your bundler, you just have to set node environment equals test. So here's a realistic example that I'm about to show called Cypress example to do MVC Redux. This is a Babel RC file. It has normal presets, normal plugins that apply in all environments. But in the test environment, we're going to instrument our code. And if you have Bubble RC, then it works with pretty much any bundler, right? Because all of them load Bubble RC the same way. So if you have a parcel and bundler combination, or Webpack and Bubble or Browserify, like it's all gonna work the same way. And if you're using something else, let's say you're not using Babel, but maybe using some specific loaders from Webpack, there's probably an Istanbul loader, right? And we collected a couple examples, a couple links to actual projects in our code coverage guide. You can go into that section and find an example. And if example doesn't exist, well, let's figure out how to do it, and we'll add the link there for everyone to see. Now, this is about to change in the next couple of months. This manual instrumentation probably will not be necessary, because once we finish full network stubbing, issue 687, Cypress will be able to instrument your code on the fly. So it's going to be a great thing, because you'll no longer have to modify anything, mess with plugins. It will become a core feature of Cypress. We are also experimenting with getting the native code coverage through Chrome Debugger protocol. We've done some proofs of concept, but this probably will come after this. So,
Gleb, I should also add, full network stubbing is one of the many features we're working on that's in our roadmap. And we often get, asked, what are you guys working on? And next week, we're going to be releasing a public roadmap for our test runner. And y'all can see everything that we're working on, including full network stubbing.
We have a very nice roadmap and lots of exciting things coming. So at this point, I want to show how this all works in practice, right? So I'm going to switch to my terminal, and I'm going to run a little to-do MVC application. So as you can see, node environment test, so my code will be instrumented. So once this started, I can reload. Let me switch to... All right, so I have my to-do MVC application. I can add things. So how do I check that my code coverage is there? If I open DevTools, I'm going to zoom a little bit. I'm going to check if there is variable coverage, and it's present, right? I can see all the source files in that single object. If I click on individual one, I can see the statements, exactly all the counters like we've seen before. So if my window has this underscore coverage object, that means my code has been instrumented correctly. The good thing about Bubble plugin Istanbul is that it generates source maps. So for actual work and debugging the app, it doesn't really matter if it has been instrumented or not. Let me switch to Cypress. So I have the Cypress test right here. Right? I hope everyone can see it. So this test just checks if I can add to-dos. I'm going to visit the page. It's a local page. I'm going to find input box with class new to-do, and I'm going to type free to-dos, and then I'm going to check if there really are free to-dos. When I run this test, I want to ensure that my code has been instrumented inside Cypress correctly, right? But I haven't lost something. So the way you check, you open DevTools just like before, you look at the console, but if you check the coverage object, it's not going to exist. And the thing is, Cypress runs your website in an iframe, so you cannot check the top environment. You have to switch to your application, and then the coverage will be there. This is a little technical detail that usually stops a lot of people from finding the right thing, switching the context, so you can actually inspecting your application. Okay, so we checked that the application has been instrumented, and we're going to have all the data, right? But here's the problem, right? How do we're actually getting this coverage information back to generate reports, right? What do we do physically? So I'm going to switch to representation. Right? So we have our coverage information inside the application. In order for us to actually save it and generate HTML reports or any kind of reports, we have to use a plugin. So we've written a plugin called Cypress Code Coverage. Okay. So this plugin takes that object, right, that gets updated during the test, that has all the latest counters, and it saves it correctly. because Cypress resets the window object, so you have to save it and then merge it. So code coverage plugin does it all for it. So the way you add it to your Cypress test, you add the plugin, you add NYC, because we're using NYC to generate reports, and you add one more peer dependency to actually merge coverage reports. And then you have to add code coverage plugins to your support file and to your plugins file. This is kind of standard thing for adding any type of custom commands. Okay, so once you do that, right, and I have done this in my application, notice when I'm running this, there are a couple of additional tasks: reset coverage, combine coverage, and coverage report. So this tells you that there's something going on, right? That there's coverage information passing back and forth. So this comes from that plugin. And I ran this test, and the coverage information has been sent to the backend, has been saved. So what does get generated? So if I see next to my Cypress folder, there is also a coverage folder generated. So there are a couple of files there. So for example, this Clover XML, it's a coverage file. This is actually information for each statement of files covered by the test. This Clover and this LCOV are two machine formats that many third-party coverage services expect. So these two reports are good for sending the reports somewhere. The final coverage numbers are saved in coverage final JSON. So this file can be used by NYC tool itself to merge with more reports, for example. The most interesting one is this LCOV report, which is the actual static HTML. All right, so let me open this one. Open coverage, LCOV, index. And let me bring it right here. So this is HTML report of all the source code that has been executed by our single test right here. Okay, so you can see the folders, the subfolders, and so on. Now, notice a very interesting thing. Even though we ran only a single test, right, it actually covered already 72% of all our statements, all of them.
Awesome.
Right? I know. It's pretty interesting how effective end-to-end tests are at exercising all your components, all the sources. Because you're not mocking anything usually if you're running full end-to-end tests. So in this case, you can kind of drill down into like where the things are missing, right? And well, let's kind of see how we can use this report. By the way, before I kind of continue, let me just show you an example of a single file. So this file, for example, was only covered at 30%. You can see the counter of each statement and how many times it was executed by that one test. In yellow, you see the statements and branches not covered. In this case, the switch statement, delete to do, edit, were not executed. So we never actually tested those things. The red are the statements not covered by our test. So at this point, we can ask ourselves, what can we do with the coverage? And the easiest thing for you to start with is to take that coverage information and use it as a guide for writing tests. So let's say complete to do wasn't covered. So let me go back to my test, right? Take the first element, find toggle button. Yeah, I have to toggle and check it. So as soon as I change my test, Cypress test reruns. So it checked that there are 3 items found the first item in my list, found the toggle element, and checked it. So I can see that my application did the right thing. And if I look at the coverage and reload this file, boom, I just hit those source lines. So I tested add to do 3 times, right? Because I added 3 items and I completed one of them. That's why the counter is 1. And so my coverage tells me exactly, just find the statement that's red, figure out what end-to-end test would actually reach the statement, and just add the test. So how does it look in practice? Well, instead of this one test, I can run the full spec, which is kind of our standard to-do MVC set of tests. There are tests for adding to-dos, for editing to-dos, marking them completed, deleting to-dos. So pretty much all the features. So let's see what the end-to-end tests give us in this case. Amir, do you think we're going to hit 80%? We were at 72, right?
I think you're going to do a lot better.
Let's see. I'm going to go back to all files.
No.
I barely missed it. 99.
That's not good enough. That's
unbelievably bad. Okay. So at this point, I just want to say that we covered, what the code coverage is and the end-to-end code coverage, but you saw that line, right? Like, so where is my coverage report? You saw that everything is at 100% except for this one particular line or edge case right here.
You always have those.
Always, right? So what is this, right? So if I look at my application and if I add an item, there are always selectors for what you want to see, right? So if I have a couple, like one item, right now I'm looking at all to-do items. I can filter and only show active items or completed, right? So my UI only is wired to 3 different states. And these states are covered by test, but this one edge case, kind of like default, kind of like a sanity check, a guard, is unreachable from my UI, right? This is just a good code. So it throws an error when you're trying to show invalid state, but my end-to-end test cannot reach it. So what do we do in this case? So we can write unit tests, and we can write unit test, get code coverage, and hit that line. So there is a hard way and an easy way. So the hard way is to take a unit testing tool like Jest, Ava, Mocha, add code coverage there. It comes built in with Jest, for example. But then you run the unit test, save unit test coverage, run your end-to-end test with Cypress, you get end-to-end coverage. And then NYC tool has NYC merge command, where you can take several JSON files with coverage and combine into a single one. And I have an example in this particular repo. But that's a hard way. Like, who wants to do it? Amir, do you want to do that?
Not at all.
Sounds like way too much.
That's not the Cypress way.
Not the Cypress way.
Not the Cypress way.
So the Cypress way would be run unit tests and end-to-end tests with Cypress, right?
Mm-hmm.
So you will get combined code coverage. So here's how it looks in practice in this particular case, is that you want to take your spec files and you want to instrument them as well. Not just your production code that gets loaded, but also your spec files that will run unit tests. And all you have to do, add this one line that comes from Cypress code coverage plugin into your plugins file. So let's see how the test looks. Where is my little test, right? What I've written for this particular case is this. So this is the unit test for Cypress. Notice how it actually imports the function get visible to those right from selectors from the application source code. And then it just, instead of loading the page, just executes a single expectation. So it's purely unit test. So I have my Cypress running here, and I'm gonna run this particular test. And the interesting thing about this, the test runs, but there is no application, right? We're not loading any, we're not visiting any website. I can confirm that my source code has been instrumented. If I switch to the iframe where my tests live, because they're isolated, there is a coverage object. So we did instrument our spec files correctly. So our unit test will provide code coverage information. And now, if I switch to my code coverage report, I will see only the selectors file. And if I drill down, I hit just that particular line, right? my unit test is very, very, very well targeted at that particular line. And the good thing is that I can go back and run all the specs, right? And so I have a combination of end-to-end tests and that one unit test that I really needed to reach that particular edge case deep inside my code. And when I run all of them together, Amir, what do you think? Are we going to get to 999, like 6 nines?
I believe in you, Gleb. I think we can do even better than 99999. I think we're going to hit the 100. We're going to do
no.
100.
Oh,
oh, look at that.
Yes. We did get it, yeah. But that's actually beautiful. So we did hit 100. And this is the Cypress way. And once we have a way to collect code coverage information from end-to-end test or a combination of end-to-end and unit test, it's not just the map. It also functions as a guard. So what do I mean by this? You can fail your build if code coverage drops below a certain threshold. And it's built into NYC report command. In this case, I'm saying NYC report, give me text summary, and also check the coverage. And if it drops below 200% for statements, which is impossible standard, right? Because the top you can have 100, it will just exit with error code. So this will stop your build. So if you, for example, set whatever threshold you want, 90%, 70, well, probably 70 is too low, 90%, 80%, your build will guarantee that your source code has been covered by a certain percentage before it's passing. A good idea is to take your code coverage report, that HTML folder, and store it and send it to, store it on CI. So for example, we run our continuous integrations, in this case, on Circle CI. So after the end of a test, I'm sending this whole coverage folder to as a static artifact. And then anyone can drill down and see if we covered or uncovered something, so we can discuss it as a team. And at some point, you will reach a limit of just like keeping track of all the coverage information yourself. So in this case, we can run our end-to-end tests on 4 machines using our dashboard parallelization service. So which means that each of the CI machines will only run a subset of tests, right? And that means that each machine will get only a partial code coverage information, right? So what do you do in this case, right? How do you combine it to get the complete picture? That's where third-party services like Coveralls, CodeCov, Codacy come into play. You can send all the partial results to those services, and hopefully they can merge those results correctly. Now, I had some mixed success with that. So in this Cypress example real-world link that you see below, I actually show a way to combine the coverage results yourself. But the good thing about those services, they can show you the coverage results really, really well so that the whole team can see it, and especially how it changes over time. So example, in this case, the coverage rows, I can click on this build. Where is it? Actually, no, let's look at this one, right? I can see where the coverage dropped, right? Which particular file, right? And drill down and see, like, this is a new line that hasn't been covered by a test. So I can see easily the changes over time to my coverage information. And another thing that third-party coverage services allow is that they can be pull request commit checks, which means that, let's say you add a new feature, you make a pull request, the third-party service like Coveralls can comment on that pull request and say, yeah, coverage remained the same. So you know that you're safe. You did not change something. So pull requests with the same code coverage or higher are really safe to merge. But let's say somehow the code coverage dropped. This is a failed check on my pull request, which says the code coverage decreased by almost 9% to 91. And in this case, you don't merge the pull request, and instead you ask yourself, why did it go down? Did I add new features and I did not write the test? Did I accidentally skip some tests for whatever reason? Right? So what happened? Did I delete some tests? And so you investigate, and you determine if it's a real cause or if you have to actually update your tests. Common error or common source of dropped code coverage, you accidentally leave it.only in your source code. And so we wrote a little utility called stop only. There's also ESLint plugin that stops you from committing or pushing tests that have exclusive tests. But to me, what code coverage provides is this nice badge that sits next to my CI badge that says 100% or 90%, right? And as long as I know that I covered the most important features of my application and it doesn't accidentally go down, like green CI and green code coverage gives me a lot of confidence in my code as I add new features, as I refactor code. But we have another surprise, right, Amir? We have something else.
So, so far you've been showing us how to generate coverage reports for our front end, right? But that's not our whole app. We also got a whole nother side to our service, which is our node backends. If we have a node. So how about combining both front end reports with our backend node tests?
1 second. Amir, can you hear me? Right, for a second.
Yes.
I lost sound for a second.
Gotcha. But we were talking about how to combine our front end and back end code reports and code coverage reports.
And you do it the same way as you do it for front end. You have to instrument the server code. And if you use NYC, just like we did before, it's really easy to do. So usually you start your server saying node and server, right? Or some JS file. Mm-hmm. If you want to instrument your code, and please do it separately, so it's not in production code, you say NYC node server. So you literally just add NYC in front of your server. And I use silent flag so it doesn't output the report because we're going to grab the report separately. That's it. So now when your server runs, it actually has a global coverage information. But information is just sitting there, so you have to extract it somehow. So in this case, I have a server. So the only thing I have to do is add one more middleware. And this middleware, again, comes from Cypress Code Coverage plugin. And this middleware just adds an endpoint so that the code coverage plugin can grab the results from the server side. So let me show how this works in practice. I'm going to start this, and I'm going to say npm run dev coverage. So I have this real-world app application. It's an example of a blogging platform. This has a real backend, real database, authentication, writing blog posts, and so on. So we started with server, started with Cypress. Everything is instrumented, the backend and the front end. So I'm going to run one of the tests, let's say like new posts spec. So this logs in the user. The user can write blog posts, as you can see, can comment, tag things. It's a lot more realistic application than just to do MVC. I'm just going to wait for it because I actually like watching Cypress, how it drives the app. Right? It's very soothing.
It's mesmerizing sometimes.
Yes. OK, so we just finished a bunch of tests that exercises adding an article. So I don't need this thing. I'm going to open the same folder. But now look at the report and look at the file names. It has client, which is our front end, and it also has server. All the routes, all the models, all the files that the server actually executed, right? In response to the front end adding new items, following a user, and so on. So one of the things that I want to show in this case is this server model folder. It has an article, right? So when we were adding a new post, we're adding an article. So everything, as you can see, actually executed on the server. And these are the typical edge cases that you will see in your server code. For example, we did not really exercise an edge case when somehow the title of a post is undefined, right? Because our front end did not allow us to add that. We also missed an edge case where the slug for an article that's determined from a title is already taken. So I have to add a test probably that adds an article with the same title and checks that a new slug is generated and doesn't override the old one. This is a typical thing where I can't even write a unit test for this case because this is completely backend code, right? So this would be something else we would have to think separately. If you want more information about everything we've shown today, we've written the code coverage guide. It's part of our documentation. It explains literally everything we went through today, from how to instrument your code to how to use code coverage as a guide, how to combine end-to-end code coverage and unit test coverage and full stack. And all the examples that I talked about, they all are there. So go to Cypress.io code coverage. And the plugin is open source. It's on GitHub. If you want, and if you have any feature requests, please, or issues, please open the issues in the repository, and we'll be happy to do more. And if you want to stay up to date with our latest features and releases, follow us on Twitter, go to our blog, and so on. And as we get more examples, we're going to put links to our code coverage guide. We're especially interested in user-submitted examples that show, for example, Angular and TypeScript, or Svelte or Rollup bundler. If you have examples where you successfully instrumented your application code and got useful information, please send us a link or open a pull request. We'll be happy to add the link so other people can see it. So I think before we go to questions and answers, Amir, we covered pretty much everything, right? That we set out to cover.
Yes, we did. We talked about what code coverage is and why you should care about it. We saw how it fundamentally works underneath the hood. Then we saw how JavaScript kind of answers the code coverage questions with tools like Istanbul and NYC. And then we saw how we can use those methods in our end-to-end tests and trickle in some unit tests whenever necessary. And then we also saw how we could utilize the reports of our backend and merge them in with our overall coverage report and to get the bigger picture. And we saw that using coverage services like Coveralls and Codacy really help with that. And so I think we told a pretty good story about what code coverage is and how you can use it today to get better insights into the coverage of your apps. If you have any questions now, let's go ahead and get them into Slido. So again, you can go to Slido /CYCC or just go to sli.do and type in this event code and then drop in your questions, and you can vote on other people's questions as well. And then Gleb and I can start answering them for you.
So Amir, are you ready for me to stop sharing and you taking over the questions?
Sure thing.
I'm gonna stop sharing.
All righty. So Gleb, are you seeing the questions that are coming in?
I do see the questions. Wow, we have some good questions. Yeah.
I think so. All right. Well, you guys are voting on all this stuff. So let's just, use democracy to our power. Let's look at the first one. So Damien, hopefully I said that correctly. Is there any way to use this to see redundant coverage? Like if there are too many tests that are wasting time testing similar or overlapping functionality?
It's an excellent question. So the code coverage plugin grabs the coverage after each test because Cypress clears your window context, right? So the coverage you get from end-to-end tests is actually tied to a particular test, which is excellent because I have a PR open that actually has a test to coverage mapping where you can see which particular lines of source code is each test hitting. So we're still exploring how to actually show it and how to use that, but you can definitely see how the tests overlap and how much of redundancy there is. So we're open to any kind of idea of how we can take advantage of that information.
Great. All righty, let's go to the next one. And maybe we can answer this one. Can we use this mechanism to measure code coverage for single page applications or a system with multiple microservices? Well, what we showed you is, yes, it of course does apply to single page applications, and it's completely, framework agnostic. It doesn't matter if it's Vue, React, Angular, whatever. We're just testing JavaScript over here. Now, with your point about microservices, I'm assuming these microservices are distinct individual systems and apps. So you would need to, apply them discretely to every single one of them. And so because their code bases, if they don't cross over in their code base, right? I'm assuming these are distinct, separate repos and don't have any overlapping code, which is how microservices typically work. Cool. All right, Gleb, so what's the TypeScript story for the code coverage plugin?
Let me see something. So code coverage, I'm trying to check if I actually ship TypeScript definitions with my source code, and I don't think I do. I'm really sorry about that. There are no types. Right, so the thing about code coverage plugin, it doesn't provide any user-facing commands. It's not like it adds site.cover or site.code coverage. So that's why I didn't write TypeScript definitions, but I will, because it's a good idea so that your TypeScript compiler knows about all the Cypress code and it doesn't scream at you. So I have to add that.
Yeah, and we're big fans of TypeScript here at Cypress. And this plugin is in its early phase, and it's only going to get better from here. Okay, so what happens when end-to-end tests are written in different repo from the actual code? Would Cypress code coverage plugin, I guess, apply in that case, Gleb?
Right, it's an excellent question. So what happens in this case is that your source code in your deployed application doesn't have instrumentation, right? It doesn't have a coverage object at all. So in this case, you have to either wait for full network proxy support so that Cypress can instrument your source code on the fly. Or I've written a code coverage proxy as a third-party NPM module that you can put in front between your application and Cypress. And that proxy can instrument your code on the fly. That project is pretty old. I've done it a long time ago, but it should work. So actually, should add a link to this as an example, because it's actually a cool example. It's an excellent question. Yeah.
Awesome. So we'll drop in a link for you all.
Yes.
Cool. All righty. So, and I've seen this kind of questions come up in the comments too. And, it is, with all this stuff regarding to our backend coverage reports applied to backends that are not written in JavaScript. So for example, Python. And what we showed today was just for Node, right?
That's right. So I don't know what actually, let me go back. As long as you can produce the code coverage information from Python in LCOF format, I believe third-party services can show that.
Can merge it, exactly.
And can merge it, right? So as long as you know how to instrument and grab a code coverage information from your language, you'll be able to just send it to your code coverage or merge it with Cypress provided code coverage. And it should just work.
And this is another one of the benefits of those coverage report services, right? They kind of abstract this extra level of complexity away, so you don't have to worry about it.
It's all like the same, like how many statements did you hit, and did you hit this one statement? So
exactly. All right. So do you recommend using Cypress as a separate project to test an application, or add it as a dev dependency and use it within your application? The way we recommend to use Cypress is to add it as a dev dependency to your current code base. So Cypress lives with the rest of your code, and it gets committed to your version control with the rest of your application. And this also makes it a lot easier to import your code in whenever you need it for maybe a specific unit test or so on. And this is especially helpful if you use our component testing libraries that we have out there, where you need to import in this your actual component code for them to be tested. So we recommend you include your tests with the rest of your code base. Though we do see people have completely separate repos for their code base as well.
Especially if you try it out, right?
Yeah, yeah. Okay, so is there a way to use code coverage to identify which APIs are getting fired as the end-to-end tests run? And I'm assuming they're referring to network APIs, HTTP APIs in that regard.
I don't know what this question might entail, because what are these API endpoints? So API endpoints and HTTP methods like get, post, patch.
Yeah.
So dear Anonymous, maybe open a GitHub issue for code coverage,
Yeah.
or maybe tweet at us and we can talk about more details. It's interesting, right?
Yeah, it's interesting to know which API endpoints you're hitting. But remember, we're talking about code coverage, right? So you were not looking at all the API endpoints you have for your system and seeing which ones got hit or not. That's a completely different coverage, right?
Right.
Story. So we're specifically talking about coverage, where we're looking at which statements in your code actually got executed.
Right.
Yeah. Okay. So let's go on to the next one. So does the Cypress code coverage plugin cost or add to the runtime? I guess the question moved around a little bit. Would it add to the runtime? And I saw this question kind of being redundant a little bit. So let me just rephrase it so we can kill a couple of birds with one stone. So, we had to instrument our code, which that's going to add some additional code to our code, right? People see that as overhead. Is that going to slow down our code, Gleb?
It will. Unfortunately, there is no way around it. You're executing additional statements. These are very simple statements, but we still add more JavaScript, more processing time. In addition, after each test, the code coverage plugin has to actually save that information. Otherwise, it will get destroyed. So it has to send it to disk, merge it with existing code coverage. That adds time. Ultimately, it's a single request before and after the test. So how much can it add? Right? Unless your application has a giant code base, so that coverage information is ginormous. But we usually advise to parallelize your test, and then you will not notice.
Yeah, I don't think I think the benefits you get from code coverage completely outweigh the minimal overhead that it adds to the execution of your code. And remember, you're only instrumenting your code during test time. We're not saying do this in production, right? So you're still going to get the actual performance that you've always had in your production systems. All right. And I really like this next question, Gleb. Will the coverage reports be visible on the Cypress dashboard? Well, you're kind of reading our minds right now, and this is a little bit of foreshadowing of what's to come. So be on the lookout.
Yeah. At this point, we might as well do it. We do anything else.
I mean, since you asked, we'll do it just for anonymous.
Yes.
Ability to turn on and off code coverage with flag to run tests faster. I mean, it's you decide to run NYC, right? When you're executing your code. So you can, conditionally in CI or whatever mechanism you have in place, choose when you want to run code coverage or not. So this is completely up to you.
Right.
Can you integrate unit test coverage with end-to-end test code coverage? Yes, that's one of the things Gleb touched on was, he wrote a unit test that got him really far in the coverage report, right? Initially you got like the 76% coverage, and then Gleb found that there was one route in the logic which was untouchable by the application's UI. So he went and wrote a unit test for that, and that gave him increased coverage. So yes, you can definitely do this. All right, Gleb. So I think we already answered this one, so we can skip that. Will you share the video and presentation in the docs as well? Yes, we will. Everybody will get links to everything you saw, the slides, and the video recording. So no worries. Is it common to merge test coverage reports from end-to-end testing with Cypress and test coverage reports generated from unit and integration test suites? Yes, so this is kind of similar to the question that was asked previously. So you can totally cover the end-to-end test coverage reports with whatever other unit testing library you're using, like Jest or Ava or Mocha independently and so on. You can easily merge that in with MYC, and also those code coverage services help a lot. All right, let's get that one checked off. So is it common to merge test coverage reports? Okay, we already read that one. Have you tried this code coverage plugin with minified.js? Does it work as expected, Gleb?
So I have not tried with minified. The thing, it should work. Minified JavaScript is still valid JavaScript, so it should be instrumentable. But the information you get back, unless you have source maps, is meaningless, right? It doesn't map back to original source code. So we're right now looking at all the different examples, like, for example, instrumenting TypeScript. As long as your TypeScript transpiler provides code like source map, then the Istanbul should also correctly get that source map and merge it so that it can correctly merge back to original source, that's called code coverage information, right? So the same should apply to minified as long as you have code coverage information. But we can only prove it by actual example, not just by words.
Gotcha. So source maps are the key there. Awesome. So let's check that one off. All right. So best practices for testing a client-side only app. Example, an app that uses third-party APIs and no backend locally. Well, hey, your life is a lot easier because you don't have to worry about merging in unit tests from your backend. You can just use the Cypress code coverage plugin and only apply it to whatever your client-side app is. Will Angular be supported? Of course. We are completely framework agnostic when it comes to the front end. Totally supported. Automatic network stubbing is just all kinds of cool. I completely agree. What is your current guess on a timeline for that to be available? Well, I can't share a time frame at this time, but it is currently being worked on as we speak. Please check out that roadmap I mentioned earlier that we will be releasing next week. And you can actually give us feedback on that roadmap site too. So please share your thoughts there as well. All right. So how would you go about testing of components? Gleb, I think we know what the answer to this one is going to be. Code which is reused a lot. End-to-end testing in each place brings overhead. Mocking its inputs might miss bugs. Gleb, you want to touch on this one?
We do have a way to run your component from different frameworks for specific adapter in Cypress, which is kind of nice. I actually like it a lot. Instead of visiting a page, you just say, give me this component, and it appears live, and you can use the same API. I haven't created an example where you actually do the code coverage for a component like that, but I don't see why it wouldn't work. So follow us on Twitter and follow the blog post, and we probably will tweet the link as soon as we have an example.
Yeah. And one thing I should also mention is that, we're actually big believers in component testing. And so, one of the things we would like to add to Cypress, the core of Cypress, is component testing itself, where you would have this ability to mount components from any framework, and then we'll automatically figure out how to bootstrap that component and allow you to test it in isolation. Cool. So let's go into the next one. So how to add stubs for any page or new link we want to visit. I'm not sure I completely understand that question. But if you're talking stubbing, Cypress can handle it. Is there a way to identify routes that aren't actually getting mocked in the code coverage report? Would be helpful to get rid of those JSON files.
So no, because we only talk about code coverage, right? This is we have no idea of what APIs there are. We have no idea which API routes are called. So unfortunately, no. Okay.
Does unit tests can be created within an application and without changing the plugins? Can we have another session regarding unit tests rather than end-to-end? Well, the thing is, the same concepts apply regardless of its end-to-end or unit tests, right? We're just executing JavaScript. Regardless of what type of test you have, the methods that we just showed today using Istanbul, NYC, the Cypress code coverage plugin, it all still applies. Remember, you can completely use Cypress to do your unit testing. No problem. Again, it's just JavaScript.
I just want to add one asterisk. As long as the code you're testing is actually browser code, right? If it can be loaded in the browser. If you're doing file system, operating system, database request, that code has to run in Node environment. And for that, you can use side task, which is not as easy as unit tests.
Yeah. So if this is all within the context of things that get loaded in the browser. So your front end code. All right.
I think we're almost out of time, right?
Almost out of time. Alrighty. So let's just do a quick look. So we only got a few questions left, and don't worry, we know who submitted what, and we follow up afterwards. So we'll be in touch. And again, you can reach me or Gleb on Twitter, or feel free to email us at Cypress. We're always glad to hear from you all and to help you out. With that said, I think that concludes our webcast for today, Gleb.
Well, everyone, thank you for joining. And Amir, it was a pleasure.
Pleasure as always, Gleb. Thank you so much. And thanks to everyone that joined the call today. Appreciate it.
Take care, everyone.
Have a good one, everyone.